Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, it's my pleasure to welcome Mike Hochella, Emeritus University Distinguished Professor at Virginia Tech and Laboratory Fellow at Pacific Northwest National Laboratory. Mike, thank you so much for taking the time to join us today. To get things started, can you tell us a little bit about yourself and how you first got involved in nanotechnology?
Yeah, my my introduction to nanotechnology, and it certainly wasn't called that at this time, goes all the way back to the 1970s when I was an undergraduate at Virginia Tech. I was taking courses in earth science. When I was in my second year of undergrad, I took a course that started teaching me about the atomic structure of minerals, and I became absolutely fascinated with how atoms arrange themselves to make minerals and make anything else, steel, biological things, whatever. Little did I know that in 1976 and 77, that would be my introduction to nanotechnology. And to fast forward, I kept doing nano-like things, although we didn't call it that, through the 70s and through the 80s and my Ph.D. in the 1980s. And then my first faculty position at Stanford, and I got my Ph.D. there as well. And I was a research professor there before I left and went to Virginia Tech in the early 90s. And in the early 90s, we started to use the words, or late 80s as well, we started to use the word nanoscience, nanotechnology, earth nano. And as far as I know, Jill Banfield, who's now at the University of California at Berkeley, and I were the first to step into this as earth scientists. Now, we're in a rich community of nano earth scientists and technologists. For me, especially through the end of the 90s and then the first decade of the 21st century through 2010, we were using all the same lingo, all the same physics and chemistry and organic chemistry and inorganic chemistry and engineering of nanoscience and technology like everyone else, except everything we did was relevant to the earth and environmental sciences. Now as I look back at my entire career, I'm thinking, my goodness, it's been quite a ride. I've just really loved my career in this field.
Just picking up on your discussion about Earth and nano, you were the founder of a center at Virginia Tech and the first director of Nano-Earth. Can you talk a little bit about the activities of that center and what you focused on there?
There is a backstory to this, which I think is very interesting. Back in the 80s, 70s, 80s, we were very lonely in what we did. I mean, we'd go to conferences and we might have, give the only nano talk in the whole conference. Certainly not the case anymore, but it was back then. In the meantime, I have two friends out there, I'm glad to say. One is the National Science Foundation and one is the Department of Energy. And as we started, submitting proposals to do this work that very few other people, if anybody, was doing at the time, they were very good to us. They trusted that we could contribute to earth and environmental science with nanoscience and technology. And again, I'm talking back in the 1980s. And we started getting everything funded. And again, fast forward to now, and I noticed that there was a nanotechnology network out there at that time called the National Nanotechnology Infrastructure Network, NNIN. And that network now is called the NNCI, the National Nanotechnology Coordinated Infrastructure. And there are 16 nodes, and we're in year 5 of hopefully a 10-year run. And I noticed that even though they were doing some earth and environmental nanoscience and technology within that network, it was far less than what we really needed. And not to take anything away from what they were doing in the 80s and 90s. And make a long story short, I suggested to NSF that I apply to make a node in the NNCI, which would specialize, very specifically specialize, in environmental and earth science, nanoscience, and technology. And it got accepted. And so now we are part of the NNCI, one of 16 nodes. Even going in this direction and creating Nano-Earth and now running Nano-Earth, it's a way for me to give back to all the support that has been given to me and my group for all of these years. In this case, we are serving the community. We're not looking inward at what we can do. We're looking outward of how we can help other people do Earth and environmental nano, which we think is a critical field in the future of nanoscience.
So, for people who aren't familiar with NNCI, this is a network of user facilities. Can you explain a little bit how people can get involved and get access to facilities through nodes like Nano-Earth?
We call ourselves a loose federation, these 16 nodes of the NNCI, and that's what NSF wants. They want us to be independent, but they want us to work together as a team, and they also want people to come to us looking that they can go to any of these nodes, whichever node will help the most, or to benefit from multiple nodes. And so if you go online and you put in NNCI, you'll get Georgia Tech's coordination website, and there you will see links to all 16 nodes and basically what those nodes specialize in. Then you can go to that individual node website and see if you think that that node can help you. That could end up where you send them a sample and they'll work on it with you or for you, or you can actually visit to actually work with their staff directly and within their labs. So every node has a very active nanoscience and technology community at their university and their partner institution. So when you go to that node, you can not only work with them, but you can work with their partners. And the whole idea is to serve the scientific and engineering communities to do really cutting edge, the absolute latest in nanoscience and nanotechnology.
So, nanotechnology naturally sits at the intersection of disciplines, and you've talked a little bit about the perspective from earth sciences. Can you share your thoughts on collaborating with other disciplines and interdisciplinarity broadly with respect to your work?
As an earth scientist, I'm used to interdisciplinarity. I'm used to having to understand a number of fields to explain how the earth works. When you're a nanoscientist, an engineer, or a technologist, you have to do the same thing. And I think the best way to explain that is just to go right to the bottom line. Again, I'll use the Earth as an example. If you're going to understand how the Earth works, you're going to have to know something about physics and something about chemistry, both inorganic and organic chemistry. You're going to have to understand something about biology, certainly. When you put all that together, along with your very specific earth science training, whether it's on oceans or the atmosphere or continents, and on the continents, whether you're dealing with rocks or water or soils or what have you have to put all those fields together. Well, same when you're a nanoscientist and technologist. And the reason is because nano is relevant to everything, whether it's biologic, or completely abiologic or some mixture between the two, whether it's on Earth or any other planet or anywhere in outer space. Whatever the universe holds, it depends in part on what happens at the nanoscale. It doesn't matter how big the object might be or small it might be, nano is always relevant. So when you're a nanoscience and technologist in general, yeah, you better know physics. You better know chemistry really well. You better know biology and so on and so forth. So this interdisciplinarity is something that every node in the NNCI really understands well. And they have staff that cover all of those fields. It doesn't mean you can't be, a super deep expert in any one of those areas. But to actually put any of your work in context in the nano world, just like in the earth science world, you really do have to be an interdisciplinary scientist. And, we're told over and over again by everybody from scientific historians to funding agencies out there that science of the 21st century is all about putting fields together and doing useful work. So interdisciplinarity seems to be the password for doing science and engineering anyway for all fields into the 21st century.
Looking back, what do you think are some of the most significant advances Earth scientists have made in understanding the Earth through nanoscience and nanotechnology?
The easy answer to your question is, even though it might not seem obvious in most cases, whatever you're interested in the Earth or in the atmosphere or planetary wise anywhere else in the universe, Any mechanism that happens on those celestial bodies will have a nano component, absolutely positively. So on Earth, let's talk about earthquakes. Let's talk about ocean circulation. Let's talk about how the atmosphere works. Whatever you pick, you will find nano components. And the good part about this for those that want to get into this field is that most of the nano components have not been thoroughly explored yet. So there's a lot of white space out there. There's a lot of open space to learn more.
What do you see as the impact of this type of research into the future?
We have a number of publications from our group over the, well, many decades now that we've been doing this, that show materials on Earth that we're even interacting with. We're breathing them, or we're touching them, or they're in our bodies for some other reason, or they move in and out of our bodies, or they're in some geologic process that's important in the functioning of the Earth. We have a lot of papers that are showing these processes and these nanomaterials for the first time. In other words, before we did that study, these materials weren't known, and therefore their function in a process on the Earth, whether it was biological or abiological, that is biologically related or not, what that function was. And sometimes those functions are really important for good reasons, like water can clean itself in the earth by groundwater running through aquifers deep in the earth, which has many natural cleaning properties. And then you pump that water in a well and you drink it without any water treatment at all. And the water is perfectly fine. And what we're finding out is that a lot of that cleansing, natural cleansing process happens through nano processes. And so it's sort of important to understand those nano processes. In fact, maybe we can use those naturally occurring nano processes to put in a water cleaning plant that we can use by engineers building it, and then we can clean water using nanotechnology to clean water that we've learned, say, from maybe some natural earth process.
So, Mike, I want to thank you again for taking the time to talk with us today. Do you have any closing thoughts that you would like to share with our listeners?
Science and technology, these are really expensive things to do. So every dollar we spend doing this research, doing our science or technology is costing the taxpayer somewhere, and this country or others, a lot of money. And there are a lot of other needs out there in society, and we better make sure that every dollar we spend in our research is really going to be useful. And that doesn't mean we just have to do applied science. I mean, fundamental science, don't get me wrong, is just as important and more important than ever. But as we do fundamental science, we should have an application in mind. So hopefully as much of it as possible will move into the applied world and it'll actually help us one day. When you look at other scientific fields, you talk to scientific historians about this and other people that think about science as a whole, and I would agree with the lists that they've come up with. On those lists are things like the science of sustainable development. If as we continue to develop as a society, we need to be sustainable. Things that we do and make have to be something that can go on for a long time and not have to be stopped because they're so destructive, clearly. So that's a big part of science and engineering of this century. Another part is energy, shifting our energy sources so they're kinder to the planet and better for the health of the human civilization. Security has become really important, and there's a lot, obviously, of science and engineering and technology behind security. And the last being climate change. We have to understand more about why that's happening and what it's doing. So I think I can conclude by saying that my thoughts for the 21st century in terms of science and technology are to keep the funding agencies healthy, to keep science relevant economically, politically, technologically, and thinking about the health of our planet and the health of the human population through all the fields that I've just named.
Thank you for joining us today for Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov. And check back here for more stories.